Okay, so I don't want to talk about what happened. I recorded a 40-minute video and it was not working. It came out really choppy. Still having OBS issues, and I don't want to hear, oh, he knows how to make an emulator, so why can't he just figure out OBS? Because it's different. It's different and it's confusing as hell. But I think I have it figured out. You'll know, because if I do, you will see this video. If I don't, you will never see this. Anyway, so I will just go over some changes I made to the emulator since the last video, and then continue to implement things. We're kind of at like a testing point. I downloaded some files that will run through the emulator and test all the different opcodes. I have so the tutorial has a couple different options. It can say you can only implement what Space Invader uses, or if you want, you can implement the entire 8080 instruction set. I believe I'm gonna opt to implement the whole instruction set, although I don't know if I'll put it all on video, because that could get boring just watching me struggle. Alright, so let's bring up the code. A few changes I made. First of all, my monitor is being blocked by light. Let's move this. Let's just move these lights up here. Boom. Also, actually turn them on. Oh no. Definitely need to edit this shit out. Okay, so things we have. So changes I've made is that instead of just running the disassembler when the app is run, I'm running the emulator, and then I am back this mic up a little bit, and then I'm just running the emulate function, which is a new function I added, but all that is doing is looping through each instruction. So it checks if the program counter is less than the amount of bytes in memory. If it's less, it'll keep going. If it's more, it'll stop. And then it'll run the emulate 8080 function, which that's what's holding our big switch statement. And on top of that, I initialize all the state variables to 0, except for the stack pointer. I have it right now at the top of the work RAM, but actually I'm gonna move it to here because that is the size of the RAM, I believe. Yes. And then so the stack pointer, I'm gonna have it at the top of the RAM. I explained some of this in the video that didn't work, but basically what I'm doing is, actually I will go ahead and show you what I'm doing from the tutorial. So we look at the memory maps section. It shows where it holds different memory things, like the range of addresses that the memory has available. So from 0 to 1 FFF is the ROM. So that'll be the actual code of the Space Invaders ROM. From 2000 to 23FF is work RAM. I believe that's RAM that is available to be used by the program. And then 2400 to 3FFF is video RAM. And then after 4000, we have a RAM mirror, which I'm guessing that is just just a mirror of the RAM, so that if something gets corrupted, there's a mirror of it. I don't know. It doesn't matter. I don't care. All right. So I'm over here at this spot. So this is just to finish up the emulator for the Space Invaders ROM, and then the next page in the tutorial is for if you want to execute or implement every instruction in the 8080. But oops, Oops. Alright, and so if we look at the instruction opcodes, we just have our big switch statement as before. I'll zoom out a little bit. Let's see. Any important changes? Yeah, so I am now initializing the memory to have a count up to the hex number 4000. That covers all the memory addresses. And then I have this little loop that goes through the ROM and then sets it just copies it into memory. And then I create the state from that memory object. So if we run it, I believe I was getting a crash at some point, but we will see. Yes, so I'm getting a crash on return. So I'm gonna print out in the debugger some stuff to hopefully explain what the issue is. But last I checked with this, when I was testing it, I noticed that the value of stack pointer was pretty big, and my guess is that it's just I'm sorry, I'm having trouble talking and thinking. I'm probably getting an index out of bounds. Okay, so what I'm doing here is I'm just printing out this number as hex to make it easier. Okay, so stack pointer is at 4000, which is at the end of the memory. So if we add 1 to it, it's gonna throw an index out of bounds. That makes sense. I'm not really sure why the stack pointer is that big right now. Yeah, because we haven't run that many instructions. Okay. Yeah, opcode C. C9 is return. I wonder why there's a return so early. Like, shouldn't return be followed by a call? So if I look at the opcodes in here, in the print, I'm just printing out the opcode. So there's 3 zeros, which is no op, a C3, which is a jump, 20, which is nothing, and then there's a return. I think that doesn't seem right. I feel like my ROM is probably not doing what it's supposed to do. So yeah, we got this. Let's read this hex. So yeah, there's the 3 no ops at the beginning. Let me make this bigger. Okay, you can't zoom in. Okay, so as we see, there's the 3 no ops that we expect. And then there's C3 is the next opcode. Yes. There should be a D4. But oh yeah, the jump. Oh yeah, C3 jumps to wherever the heck. Okay. So, and then we jump. We end up here probably. Or one of these 20s. Yeah, let me look at C3. So we're just implementing jump. So that just sets, okay. Maybe, yeah, I think I'm missing something from my jump call, and that's why we're getting issues here. So let's go back, check out the branch group. This takes a second to load because it's using the Wayback Machine. All right, so all it does is set the program counter to opcode, the next 2 opcodes, okay, which is the address. Let's take a look at this. Okay, so, I feel like I might actually be having an overflow issue here. So, okay, so what I think is going on is so when I shift the memory over 8, it is overflowing because that's held in an 8-bit integer, and when you shift it over, it needs to be in a 16-bit integer. I believe that C might do it automatically, but I could be wrong. We'll see. Okay, yeah, I think that fixed it because we're getting a different error. Okay, now we're getting an unimplemented instruction, so I believe, yeah, the opcode is gonna be 6. Make sure I'm in the right place, so I'm gonna print it out. Yeah, 6. Okay. Yeah, 6 is unimplemented. Take a look at the tutorial again. So see if that is one that is used in. Yep, it is used, and I did not implement it. That's MBI. Okay. So we need to implement that one. I believe the move instructions we did not implement. Yeah, we did not implement the move instructions. Open up the data book. Oh wait, did. Oh well. No, we did not implement moves. So, yeah. According to the tutorial, moves are trivial to implement. So, we'll see about that, bud. I am pretty stupid, so it's possible that I won't find it trivial. No, I shouldn't say that. I'm a smart person, maybe. Alright, let's see. Oh my god, what is going on? This shit's scrolling like crazy. Going nutty mode. Alright, actually, let's take this out of full screen because it's acting weird. Alright, instruction set. Move would be part of the branch group? Or no, the data transfer group. Okay, so move constant register 2 is moved to register 1. Okie dokie. Move from memory, move to memory, move VI data. Byte 2. Instructions move into register R. Okay, yeah, let's just move immediate. Okay. This is should be mostly trivial. So actually, before I do this, I'm just gonna go ahead and comment that out. I'm gonna create helper methods once again. I'm gonna move this instruction to my second screen so I can look at them in secret. Okay, so anyway, let's see. So we got move immediate D8. That is, first of all, I'm gonna just implement all the different move instructions. Okay, move B into B, move B into C. Okay, so each one has their own one of these. So I do move C. Yeah. Close. Oh yeah, there it is. Okay, so and then after that, so A. Okay, that's all the helpers I need for move, and then I just have to do move immediate. Also, I want to say that I have to also move the program counter because some of these take 2 cycles. So, okay. So, I actually think I'm fine just for the instructions that operate on multiple bytes. I have to increment the program counter. Move memory. That one I have to add 1 to the program counter. Move immediate. Also is add 1. So that will be. I think if I get a bug, then I'll know why. It's because I didn't increment it enough. Okay. So implement all the helper functions. So all we got to do is throw those where they need to be in the switch statement. So I will be on this. Okay, so I have implemented and called all those things. Only thing I noticed there's a halt here, and not sure if that's required. So let me check the instructions once again. I'm sure it's pretty trivial to implement that if it is required by Space Invaders. If not, I'm just going to I'm gonna skip it for now and come back to it when I'm ready to implement the whole thing. So let's see. Alright, we're having an issue on call. Okay, so again, let's print out the stack pointer like that. Yeah, so it's at 3FFE. So my guess is that we're having an issue. Another index out of bounds issue. So let's debug. Okay, Let me take a look at the instructions once again. Go ahead. Put them over here. Okay, my guess would be another issue with the casting. So yeah, again, I'm casting this value to, well, no, actually this is already. Okay, so I don't have to cast that because it's already a 16-bit integer. And then we shift it to the, yeah, I believe we're shifting it to the right, eight spots, and then ending it with 255. Okay, so, okay, yeah, and then we're, so that's what's happening there here is we're converting it to an 8-bit integer. So I don't believe that's the issue actually. So let's see. All right, I'm gonna put a breakpoint right before that. Actually, right here. So yeah, at this point, stack pointer is 4,000 because that's where I initialized it. So maybe I don't want to initialize it at 4,000. Let's do it at the top of the work RAM group, see what happens. So I got an invalid. I must have actually gotten rid of that breakpoint. Okay, so invalid opcode at 21. So what is 21? 21. It is LXI HD16. Okay. Yeah, so that is another one I have not implemented just yet. So let's go ahead and do that. Let's take a look at the book. Well, I will. Okay, so LXI is load register pair immediate. Okay, so I have to implement all the LXI ones as well. Okay, so I believe that's just 3 because there's only 3 register pairs. B, D, H. Yeah, okay. B, D, H. Don't remember which one is the high bit and which one is the low bit. Let's see if there's. Actually, it probably says it in the tutorial. So let's take a look. Okay, byte 3 goes into B, byte 2 goes into. Okay, so yeah. Okay, is that all? Let's do okay. Okay, now we just got into the switch. I already have H1 in there, and then that's gonna be 1. Oh yeah, I forgot to implement the program counter. Yeah, so earlier in the tutorial it showed me how to do this actually, but I'm gonna replace it with my actual helper method. Okay, and then 11 on H is already in there. Okay, that's 21 H though. Alright, so another issue, arithmetic overflow. Okay, so I'm gonna print whatever's in the memory at that offset and then see what could be the issue. But I think I know what it is. Probably just that we're getting an overflow, or an underflow actually, because it's 0. Then we're subtracting 1. Alright, let me see what this opcode is supposed to be doing. Yeah, decrement the register, so it's very useless. Docs, thank you. So this is just decrementing whatever's in the memory at that offset, and it's 0. What is answer? Yeah, answer is going to be uint 8. So I believe I may need to make this a signed integer, or, well, okay, so first I'll explain what the bug is. The bug is this is operating on an unsigned integer, which means it can only be positive, and because this is 0 and we're subtracting 1 from it, it makes it negative, and that doesn't work. So that causes an underflow, not an overflow. I guess it's the same thing. So let me think about this. And my camera's about to die, so I think I'm going to call it here and come back a little bit later. Okay, so I fixed a few issues, some like typos and then some like logic issues with where the program counter is. Right now I'm just going through and debugging. It's a very manual process, so I won't actually film that and put that in the video, but I will show you what I'm doing quickly, and then we'll probably call this video a day. Let me grab my window. So this is very tiny. All right, so here's what I'm doing to debug right now, and don't make fun of me. Don't leave comments saying write unit tests. I don't feel like it, so I'm just gonna do this. So what I'm doing is, this is a emulator online written in JavaScript. The nice thing about it is it has Space Invaders built in, and then you can run each opcode one by one, and then look at the state of the project. So as you see, as I run one instruction, it updates the program counter, the flags. Run another one, updates again. You get the idea. So basically, I'm just running through, and in my code, what I'm doing is each time I run the emulate 8080p function, I'm printing out all the state of my state the state of my state object, my state, each register and the program counter, stack pointer, and the flags, and then I have a breakpoint right after that. So down here in the console, you can see it prints it out, and literally all I'm doing is comparing the two. Yes, very manual, but at the moment, this is how I'm choosing to do it because I'm lazy, but not lazy enough to automate things. So for that, I'm just gonna go through, try to debug the emulator, get everything hopefully behaving correctly enough to move on to the hardware section. So I will pick that back up in the next video, but thank you for watching. I will be back probably, hopefully in a few days with a new video. And please like and subscribe. Thank you. And I've been Maddie. Bye-bye.